Question 25. Here are two triangles, T1 and T2. The lengths of the sides are in centimetres. The area of triangle T1 is equal to the area of triangle T2. Work out the value of x, giving your answer in the form a plus the square root of b, where a and b are both integers. We can remember that the area of a triangle is given by half times the base times the height, which helps us with triangle T2. But T1, we don't know what the height is. But you are given a formula in the front of your exam books which tells us that the area of a triangle is equal to a half AB times the sine of C. And this is used when we have a triangle that's not right angled, but we know an angle and the two sides either side of it. So we're going to find and write down expressions first for the areas for each of these triangles, and then by making them equal to each other, we hopefully should be able to solve it and find out what x is. So for our first triangle, T1, substituting into this formula, we have a half multiplied by a, which is, and b, both of those are x, multiplied by the sine of 30 degrees. Now looking on our calculators, the sine of 30 is a half. So essentially what we end up with, the area of triangle 1 is a half times a half, which is a quarter of x squared. For our second triangle, T2, we're going to have a half multiplied by the base, which is x minus 2, multiplied by the height, which is x plus 1. Multiplying out our brackets, we can get x times x, which is x squared. X times 1 is x, minus 2 times x is negative 2x, so that leaves us with a negative x. Negative 2 times 1 is negative 2. Now with those two values, we can write those equal to each other. I'm just going to rule off here because that's our background calculations completed. If we make those equal to each other, we should be able to solve this to find out what x is equal to. So firstly, we know that a quarter of x squared is equal to a half of x squared minus x minus 2. To get rid of those fractions, we can multiply by 4. By multiplying by 4, we end up with x squared on the left. And that's equal to, well, a half times 4 is 2, so we're now dealing with whole numbers, which is easier. 2x squared minus x minus 2. If we multiply this out, we end up with x squared is equal to 2x squared minus 2x minus 4. With a little bit of rearranging, we can take away this x squared from both sides, and we get this quadratic x squared minus 2x minus 4 is equal to 0. Now if we want to find a value for x in this format, we have to do one final stage of rearranging, and that's to move our constant value over to the other side. So we'll still have x squared minus 2x is this then equal to 4. By adding 4 on both sides, it's moved on to the other side. From here, we have to try and complete the square. So you take our value here, say x, and a half of this, which is minus 1, and square it. So x squared is x squared, minus 1 times x, and minus 1 times x is minus 2x, but then we still have minus 1 times minus 1, which is plus 1, which we don't want, so we have to take away another 1 from this side. Almost there. If we want to leave just this on its own, we can add 1 to both sides, which gives us x minus 1 squared is equal to 5. So now if we solve this, we can find out what x actually is equal to. Firstly, we'll find the square root of both sides to remove the square symbol. So x minus 1 is equal to the square root of 5. To get x on its own, we can add 1 to both sides, which gives us 1 plus the square root of 5. This is in the format of a whole number plus the square root of another whole number, and that is our final answer.